What happens when the most successful designer in history is given total freedom, an unlimited budget, and a legendary driver hungry for glory? What if I told you that this car already exists, and that it could completely rewrite what we understand by a Formula One car? To understand the true revolution that the AMR26 represents, you have to look closely at the way it was conceived. Adrian Newey did not come to Aston Martin to make one more car. He arrived with a philosophy that has been the secret behind some of the most dominant cars in history. But this time he applied it without restrictions. The AMR26 is the first car in decades to be designed entirely from the outside in, completely reversing the traditional development model. In most teams, the design of the car begins with the power unit. The engine defines the size, the shape of the chassis, the cooling needs, the weight, the anchoring points. That is, everything else revolves around that centerpiece. But Newey completely changed the rules of the game. He first established the ideal aerodynamic parameters. He thought about how the air should flow through the car, where each surface should be placed, each channel, each spoiler. And once he had that clear vision, he went to Honda and said, "Now make your engine fit here." This approach created an earthquake within Honda's Sakura division. The 2026 engine, already a colossal technical challenge due to the elimination of the MGUH and the massive increase in electrical power, had to be redesigned from scratch to fit the chassis Newey had drawn. The RA626H is not a simple competition engine. It is a compressed, optimized work of engineering, almost surgical in its construction. Honda had to compact not only the thermal block, but also the hybrid systems, batteries, cooling, and heat exchangers, all so that they did not interfere with the airflow designed by Newey. But it wasn't just a matter of size. It was also a question of thermal efficiency. The ultra-compact design required cooling solutions never before tested in a Formula One car. Traditional air inlets were eliminated, radiators with experimental geometries were implemented, and every cubic centimeter of the car was exploited to keep the assembly within acceptable thermal margins. This level of structural compression is only possible when there is perfect alignment between the design department and the engine manufacturers, and that was one of the most complex achievements Aston Martin achieved on this project. Newey also pushed the new 2026 wheelbase rules to the limit. While many teams opt for more conservative configurations, the AMR26 has been built with a minimal wheelbase, within the narrowest margins allowed by the regulations. This decision responds to an obsession with cornering agility, particularly on technical circuits where every meter of reactivity can make the difference between the podium and irrelevance. A shorter wheelbase also means less rotational mass, better cornering ability, and less inertia when changing direction. But it also introduces monumental challenges in stability and traction. Newey is betting that, with smart suspension and pinpoint weight balance, it can master those challenges. And to ensure that precision, war has been declared on every gram. The car has been designed to be below the minimum permitted weight, 768 kilograms, which will allow Aston Martin to redistribute the ballast in strategic areas to fine-tune the balance. This strategy, used masterfully by Red Bull in its years of dominance, allows you to change the character of the car without modifying the mechanics. The AMR26 is built with titanium and carbon alloys, exotic materials in areas where other teams still use aluminum or standard composites. Even hybrid modules, such as the MGUK, have been redesigned to minimize their mass and allow for more centralized integration. The system developed by Newey is based on two operating modes: X mode for low-load areas such as straight lines, where the car reduces its air resistance to a minimum, and Z mode for curves, where the aerodynamic load is increased to maximize grip. But it's not just a matter of raising or lowering a flap. The entire design of the car is designed so that the airflow adapts organically to these changes. From the side channels to the rear diffusers, passing through the barge boards and internal ducting, every millimeter of the AMR26 responds to the need to maintain perfect balance in these dynamic transitions. What this allows is a total optimization of each phase of the turn. Instead of compromising the car's setup for a compromise between straights and corners, the car can now be the best in both scenarios. And this, in the hands of a driver like Fernando Alonso, represents a monumental tactical advantage. Alonso will literally be able to change the behavior of the car in each sector as needed, exploiting his strengths as a driver: precision, reading the track, and the ability to adapt in real time. The second major axis of the AMR26 design is the fight against weight. The 2026 rules set a minimum weight of 768 kilograms, but Aston Martin has designed the car to be well below that figure. Because all the additional weight up to the minimum can be used as ballast, strategically redistributing it in areas of the car that improve the center of gravity, mass balance, and dynamic response. In practical terms, this allows the car's behavior in braking, traction, and lateral support to be fine-tuned without changing any structural component. To achieve this, the team has implemented high-tech materials, combinations of titanium with carbon for the MGUK shell, composite fibers with ultralight resins in the body, and even internal structures optimized through generative algorithms that simulate hundreds of thousands of structural loads to eliminate unnecessary material. It is a level of engineering that borders on aerospace science. In addition, each auxiliary system of the car has been miniaturized or relocated to free up space and reduce weight, from the hybrid system batteries to the heat exchangers, including the control electronics. The cooling system has been redesigned to reduce the front section of the car without compromising thermal reliability. This not only improves airflow, it also reduces resistance, key to maximizing energy efficiency in a car that now depends 50% on its electric propulsion. Finally, the AMR26 represents a visionary reading of the 2026 rules. Where others see limitations, reduced thermal power, increased weight of the hybrid system, greater operational complexity, NUI has seen an opportunity to redefine what it means to be fast in Formula One. The combination of adaptive aerodynamics, ultralight weight, and electrical mechanical balance positions Aston Martin as the only team that has interpreted these rules as a starting point to innovate, not as an obstacle to overcome. All in all, this is not just a new car. It is a technical manifesto, a declaration of intent. The AMR26 is not designed to comply with the regulation. It is designed to dominate under it. But that ambition, as always in F1, comes at a high price. Because the more complex the system, the thinner the line between genius and disaster. The development of the AMR26 seemed to be going according to plan. Adrian Newey's radical ideas were taking shape. Honda was collaborating like never before, and every part of the car was beginning to come together in a technical symphony that promised to revolutionize Formula One. But it was just when everything seemed to align, when the project suffered its most unexpected blow. A data correlation crisis directly originating in the wind tunnel. Silverstone had launched a state-of-the-art facility, with the promise of being one of the most advanced tunnels in the world. It was supposed to become the aerodynamic validation core for Aston Martin's future. But in the midst of developing AMR26, Newey detected something disturbing. The data released by the tunnel did not coincide with the results obtained in CFD, computational fluid dynamics, simulations. More worryingly, they did not align with predictions generated by mathematical models or historical baseline data. It was a red alert. What was being built could be based on a false reality. These types of problems are more common than you think in F1, but the difference is in how you react. Newey, with decades of experience building championships, did not hesitate. He stopped the development of the car. He ordered a complete recalibration of the wind tunnel, a decision that cost weeks of delay and millions in discarded tests. But it was the only way to avoid a catastrophe later. Their reasoning was simple. Building a car on bad data is not only inefficient, it's suicidal. Formula One does not forgive basic mistakes. A bad design, even if it's great in theory, doesn't win races if it's misaligned with the reality of the track. The problem went beyond the technical. It was a philosophical question. Newey demands perfection in every step of development. And realizing that the tunnel was delivering data that distorted the behavior of the real flow, he didn't just ask for minor adjustments. It rewrote control algorithms, rethought calibration protocols, and forced a review of previous model simulations to find the source of the mismatch. The internal investigation revealed that the system had been previously calibrated based on measurements from the AMR25, a car that, while competitive in certain contexts, had a completely different aerodynamic behavior than that intended for the AMR26. This tainted heritage was the root of the problem. The analysis tools were conditioned by a previous car concept. And that, in Newey's world, is unacceptable. The decision was drastic. To redefine the entire simulation environment, from the software to the physical sensors in the tunnel, and build a completely new database. This process delayed key design decisions, such as the rear suspension or the final flatbed configuration. It even forced the internal structures of the car to be modified to accommodate new aerodynamic readings that had not been detected before. In the end, the wind tunnel crisis will be remembered as a turning point. Not because of the damage it caused, but because of how it allowed the car to be reborn with more reliable data, with greater precision, and, above all, with new technical confidence. From that moment on, every decision at Aston Martin was made knowing that the tools were as reliable as the brains that operated them. The AMR26 was back on track. But the message was clear. It doesn't matter how revolutionary your car is if you can't trust what your instruments tell you. In Formula One, the truth begins with the data, and victory with the humility to question them. As the AMR26 approaches its official track debut, the question hovering over the paddock does not have a simple answer. Are we facing technical genius that will change the course of modern Formula One, or an act of arrogance disguised as ambition? Is the AMR26 the pinnacle of automotive design, or a living warning about the dangers of going too far too fast? Because what Aston Martin has done with this car is unprecedented. They have not sought an evolution, not even a discrete revolution. They have completely broken with the unwritten rules that govern the technical development of F1. They have inverted hierarchies, rewritten methodologies, taken risks that very few teams would even dare to pose in a design sheet. The AMR26 represents the highest expression of Adrian Newey's thinking when given carte blanche. A car built with a total obsession with efficiency, lightness, agility, and adaptive aerodynamics. But also with such complexity that its margin of error is microscopic. And that poses the real dilemma. Because every AMR26 innovation is a potential source of advantage or collapse. The extreme compression of the aerodynamic package can make it the most agile car of the year, or the most unstable. Active aerodynamics can give you absolute control of airflow, or such critical dependence on sensors and software that a minor failure would compromise the entire lap. The new Honda engine architecture, redesigned by external demand, can be a marvel of integration, or a source of structural weakness and compromised reliability. What Aston Martin has done with the AMR26 is a statement. They are not here to score points. They are here to break the established order. To show that F1 can still be a field of geniuses, of crazy visionaries, of minds that see beyond the regulations and the stopwatch. And that, in an increasingly standardized and predictable world, is an invaluable rarity, an incalculable risk, and maybe, just maybe, the spark of a new era. Let me know in this chapter what you think about all this.